yeah, there's essentially a new Solana Czech Republic community been growing. So I think you guys definitely wanna join maybe some workshops or just co-working spaces and stuff. Yeah. Cool. Let me make sure that the recording is happening. Yeah, I think we're all good here. All right, Fireflies is taking notes in the recording, so it seems that we're all set here. Yeah, thank you so much for joining. First of all, I'm gonna just continue admitting people on the background. I think we'll have probably some more people gonna join within the next 5 to 10 minutes, but I think we can start with some intros on your end. And yeah, the floor is yours, Andrej.
All right, so I will take it slow. So first thing, let me share my screen so you can see the presentation. All right, yeah, can you see the screen, right? The presentation.
Yep.
Okay. So I can see that people are still joining, but yeah, I will continue, and I would say the hands-on, which will start approximately the half of the presentation, is much more important than the introduction. So I will just start. So yeah, welcome everyone. Thanks for joining. My name is Andrej, and today I will be talking about the art of manually guided fuzzing with the Trident. So, as an introduction from my side, I'm the lead Solana auditor at Ackee. I'm the main developer also behind the Trident. We have a team dedicated for that, but I'm the main dev. And yeah, that's basically everything. We also have a team for the Ethereum and the EVM. So yeah, the second team is auditing EVM scope. They also have their own fuzzer. It's called Bake, and it is also manually guided fuzzing. So that was the inspiration for the Trident. Maybe some brief history. We've been developing the Trident for already some time. We tried different approaches. Maybe some of you already know HonkFuzz, AFL, black box fuzzing, etc. But with the latest releases and in the few previous weeks, we decided that we want to go with the manually guided fuzzing, because we think that's at the current state of the Solana is really superior to the black box fuzzing. But I will be talking about that later during the lesson. Yeah, this was my introduction, and I think we can go directly to the lesson. So, as you already know, Solana is growing. Solana is growing really fast. This can be seen on the TVL metrics. There is also the latest update, and these are basically the X stocks. So you can now trade the X stocks or stocks on the Solana. So the real world assets on Solana are really growing, and Solana is becoming internet capital markets. So all of the assets from the world are basically going to the Solana. Also, not just Solana, but yeah, I understand that also Ethereum is really important and other chains, but Solana, due to its speed and the performance, has definitely played between other chains. What that means? That means when there are a lot of assets, a lot of hackers want to steal the assets and hack the protocols. For that, we need to ensure that security is actually in place. And yeah, that's why we decided to continue and to develop the first fuzzer, because currently, if you have a look at the ecosystem, I think there might be a lack of quality tooling / testing regarding the security of the smart contracts. When you create a new project protocol on the Solana, you try to start a new business, the first thing you do is you develop the protocol, and then you write unit tests, integration tests, you decide to undergo audit. That's really nice. Both are pretty important, but there are no more additional options that you can actually take, because you write the integration test, you can properly test your smart contract, but fuzzing is superior to the integration test. You can write the unit test and then undergo audit. You can choose the formal verification, which is also, I would say, a pretty interesting testing technique, but it might be sometimes sorry, I was muted. Is everything all right? Did you hear everything?
No, we heard everything. You just cut for maybe half a second.
Oh, okay. Okay, so yeah, I was talking about the formal verification, which is interesting method for ensuring security, but yeah, it might be costly, it might be time consuming, etc. I would say you need a third party to perform actually the formal verification. So I think there is this gap for the fuzzing, that because fuzzing you can create a fuzz test by yourself, and they can cover basically the whole logic of the smart contracts to ensure the security. Additionally, the fuzz test actually ensure the stress testing of the smart contract, because when you write the integration test, you just create a TypeScript test. There is some kind of flow with the 15 instruction executions, and that's not actually stress testing the smart contract. You need to execute thousands, tens of thousands of transactions within the seconds to actually stress test with random numbers the smart contract. So that's actually the point of the fuzzing. You may ask, for those who don't know yet, what's the fuzzing actually? So I have this quote which says that the fuzzing is a testing technique. So keep in mind that it is testing technique, but it allows you to use random, valid, invalid, or completely unexpected input data to your program, to your software. I say software because fuzzing is not related only to the Web3 security, but also related to the Web2 security. There are numerous bugs that were discovered, I don't know, for example, in the Google using the fuzzing. So it is pretty well known in Web2 security. That's also one of the points why we want to bring it to the Web3. And yeah, this helps to discover unknown bugs and vulnerabilities, because as the data are random, you just don't try to insert one exact number to the smart contract, but you can specify the range, and the fuzzer will automatically select random numbers from this range. So that's basically you are covering the whole all of the edge cases, the middle cases, etc. With a slight joke, how you can think about the fuzzing. So fuzzing is something like a tester goes in a bar and he orders 1 beer, 2 beers, 3 beers, 88 beers, 0 beers, or minus something, some huge amount. So that's in principle classical fuzzing. If you understand the classical fuzzing, I would like to move to the manual guided fuzzing. And in the manual guided fuzzing, which is the Trident, there are some preconditions which can help you to better focus on the smart contract that you're actually fuzzing. So instead of just ordering beers, you have these conditions. So for example, on Monday, you order 0 beers. On Tuesday, you order something less than 5. On Friday, you order completely random, a random amount of beers. So you are actually somehow guiding the fuzz test to better perform on your smart contracts. Just an example. Why is it important? From the experience as an auditor, most of the, I would say, 99% or even 100% of smart contracts expect some kind of sequence of flow. So let's say your smart contract has 15, 17, 20, maybe 10 instructions. It is not suitable that the instructions will be executed in a random order or in some kind of random permutation of instructions. However, they are expected that at the start, there are maybe 1, 2, 3 instructions that are dedicated to the initialization. So initialize metadata, initialize global config, initialize user, etc. In the middle, there will be most likely some instructions that might be performed in the permutations, so maybe swaps, deposits, withdrawals, borrowing, lending, etc. And at the end, there are, however, some instructions that are dedicated to the terminating of some accounts, some states, etc. So, for example, fees withdrawal, closing some accounts, some user accounts, etc., etc. So the smart contract is by default not meant to be executed completely random, but with this some expected sequence of instructions. So what you want to do in your fuzzer is that specify these three instructions should be executed at the start. Then we have these 5 instructions which should be somehow permutated in the middle, and then at the end execute these 3 instructions which are terminating some states. What can be also addition is that to specify how many permutations should be there in the middle, how long the permutation should be. So you specify that there are 3 instructions that you want to execute as a permutation, but the length of the permutation should be 100. So create me random sequence of 100 transactions, instructions from these 3 instructions. That's power of the manually guided fuzzing in order to stress test the smart contracts. All right, so I already can see some messages. So we will definitely have time for the questions, but now I would like to continue. So what are the advantages and disadvantages? So there are advantages such as dedicated to the protocol needs. So that means when your smart contract is dedicated to the borrowing, you can write fast test for this particular smart contract. If the smart contract is dedicated for the gaming or something completely different, the fast test, it is like the integration test. So you just write the integration test particularly for the smart contract, not for any smart contract in general. It also covers edge cases, so we or the Trident does not use like the one number all of the tests, but it generates random numbers from the range. It also can generate permutations, for example, accounts. So these are edge cases, not the expected happy paths as the developers most of the time write. What is important from my point of view is that it mimics real-world environment. So in the Trident, it is possible to dump the smart contracts from the DevNet, testnet, mainnet, whatever you want. Also, data accounts you can dump from them. So I don't know, for example, from Camino, you can dump the Camino, and you can dump also config accounts of Camino. So you can basically take the mainnet state to your local testing environment. And what is also important is that there is no such thing as abstraction or approximation. We basically take the logic as is written in the smart contract. The smart contract is deployed in the local fuzzing environment. Then you write the fast test and you leave it run for, I don't know, 1 hour, 30 minutes. That's already quite some time. But in 30 minutes, it will process millions of transactions. And if you have really nice invariants, you can be almost 100% sure that the smart contract is safe. What is disadvantage is that, as I said, it is manually guided. So you need to have some kind of knowledge about the protocol, and you need the fast test to guide it slightly. So as I was describing the instructions, you need to know which instructions should be executed somewhere at the start, which are meant to be executed somewhere in the middle, and then which are the terminating instructions which should be executed at the end. There might be also some different cases when you need to know what data accounts are stored, where the data accounts are stored, I mean on what PDAs, what are the limits stored in the data accounts, etc. So this can be slight disadvantage because it is not so black box. You just don't initialize the fast test and then immediately run it, but you need to guide it, write it. You will see in the hands-on example. Now going to the Trident, so we can talk slightly what the Trident is. So as I said, Trident is a manually guided fuzzer. And in principle, it is Rust-based CLI. You can just go to the crates.io, in the search type Trident-CLI, and you will see the command how to install it, cargo install Trident CLI. You can also install specific version. And in principle, it just builds the Anchor project. And from the Anchor project, it takes the idea that is created, and from the created idea, it generates fastest template. So it is this simple. We don't have some additional logic that would, basically in principle, if the project can be built with the Anchor build, it is possible to initialize the Trident within the protocol. It has fast execution. We will also see this during the hands-on example, because it can process hundreds of thousands of transactions during few seconds. So we will see that. And yeah, there are multiple features to go as close as to the mainnet. So for example, the stateful fuzzing. Stateful fuzzing means that instead of selecting completely random data, this is also connected to the manually guided fuzzing. Instead of selecting completely random data, you can specify in the fuzz test that fetch this account, have a look in the account, and for example, in the account, there is stored some kind of deposit limit or something like that. And if the deposit limit is stored in the account, you can generate the numbers such that the deposit limit will not be hit at any time. So the numbers are more specific to the instructions, to the protocol, not just completely random. We also created the dashboard, so we will also see the dashboard. The dashboard is really appealing because you can see how many transactions were running, how many invariants failed, how many times the instruction panicked, what were the errors during the errors returned by the instruction during the fuzzing. And there are simple metrics to see how much entropy the inputs have, etc. I will show you this during the hands-on example. And the invariant checks, for those who don't know what the invariant checks are, you basically execute the instruction, and the instruction can change state of some data accounts. So it's a really simple example. You have some kind of counter in data account, and you have instruction update counter, and the instruction just adds 1 to the counter. And with the invariant checks, you can specify that, yes, when we execute the update counter instruction, the counter should be always increased by 1. This is a really simple example. So in this case, it wouldn't make much sense, but in a more complex and difficult scenarios and cases, it is really nice because you can actually check that every data account updated in the instruction is updated as expected. Exactly. Invariants, some condition that should always exactly. All right, this was introduction. I would like to show hands-on example right now, but for now, if you have any questions, I think I can answer some. So if something is not clear enough, just feel free to ask. Okay. Yes, oh, let me open the chat. How widely used is Trident? So Trident is currently used, for example, we are working, for example, with the Camino. We have 300 stars on the GitHub. There are some issues already opened. So yeah, we do not have any particular statistics about how many users use it, but yeah, I think it is gaining the popularity, I would say. If you can use the Trident for GitHub pipeline, for sure, that is possible. And if you have a look in the Trident repository, there are actions. And yeah, you can have a look into the actions because we are actually running the Trident in the GitHub pipeline when we are merging PRs. So you can have a look how we are performing that. But it is pretty simple. You basically need to build the binary, and then on the initialized or on the fast test, you just need to run the Trident fuzz run. You will see in the hands-on example. Can we fuzz it on on-chain state? Yeah, we are currently in the process of developing the fork testing, but something like a completely live on-chain state is not possible. But as I described, you can, before the executing the fuzz test, you can dump the state from the mainnet included in the Trident SVM. It is, if you ever included some program or account within the Anchor, I mean within the Solana test validator, in the local Solana test validator, using the Anchor Tomo with the Trident, it is pretty similar. So yeah, you can do that. But we are working on the basically fork testing, which would fork the mainnet state if it's required in the fuzzing session. All right. What is the benefit of using Trident compared to Cargo Fuzz if we have to write the invariance manually? It is already some time that I used Cargo Fuzz, but yeah, the Trident is more dedicated to the smart contract. That's the first point. The second point is that if I remember it correctly, you can just take the logic from the smart contract, insert it into different binary, and then fuzz the binary with the specific logic. But the Trident allows you to actually execute the whole instruction, also transaction with multiple instructions. So this is like basically fuzzing transactions, Solana transactions on the local validator, if I can say it like that. By default, our instructions are executed in order in this. Sorry, I don't understand the question. By default, I don't understand the question. By default, our instructions are executed in order in a smart contract. I will go to another one. How do I handle Solana account data during fuzzing? What do you mean by that? Because yeah, it is so far it is kind of problematic to deserialize the data in the invariant check, but we are currently working on that. Apart from that, the Trident SVM basically stores the data accounts in its own database. So yeah, if your smart contract initializes the data account, you don't need to do basically anything. Does fuzz testing cross into benchmarking at any one point? If you mean that, yeah, we are not yet collecting compute units consumed, if you are asking for this. But yeah, this will definitely be on the roadmap, and we can include the consumed compute units in the dashboard and in the metrics, if you mean compute units by benchmarking. Do you have any ideas how create command for migration for Trident tests? Yeah, so the Trident should support the ideal of the Anchor 29 and also 30 and also 31. If I can remember correctly, there were some significant changes between 29 and 30. So in terms of this, it should be all right. In terms of different anchor length used within the smart contract, it should be also all right, because if you did not change any logic in the smart contract, or important is interface. So if the instructions are as they were previously and you just updated the anchor length version, it is completely enough if you just build the project and include it in the fuzzing using the Trident Tomo. So there is no difference. But yeah, if you, so the migration should be easy. But yeah, however, if the interface changed, I mean, the ideal is different, then yeah, you would need to make changes to the fuzz test by yourself, unfortunately. Sorry, is Trident a coverage guided fuzzer, and how do you mutate the inputs randomly or using something like a dictionary based approach? Okay, this is a really nice question, and yeah, so Trident was using coverage based fuzzers, and this is likely okay. We have still some time. We've been using coverage guided fuzzers, and we've been using AFL and the home fuzz, but we noticed that there is a lot of bottleneck using the home fuzz and the AFL because fuzzing was drastically slower when we were using these fuzzers. So we decided to go with the manually guided fuzzer, and the difference is that we don't so far we don't think it is like necessary to do something really difficult with the random numbers to do mutations, etc. So for that, if you have inputs such as integers, strings, what we do is that we generate the inputs completely random. We noticed that when we were using the AFL and the home fuzz, the fuzzers tend to learn which inputs are correct for the coverage to increase, and they were repeating these inputs a lot. Additionally, the fuzzers generated a lot of data, and if we were mutating, for example, just 8 bits or 10 bits in the generated random data, then there would be a just small number of changes in the final data. So these are just a few mutations to actually efficiently fuzz. However, if we can specify that each number is random from some range, the distribution is actually uniform, and there are much more variations to the instruction inputs. Yes, by default, Solana executes instructions in the order they appear in the the transaction, that's true. But if multiple instructions interact with shared accounts, Solana process them sequentially to maintain consistency ordering methods unless you're doing safe operations. Okay, that's not a question. What is the best way to write the setup? Is there way to automate or optimize this step, perhaps by writing a script that allows for easier configuration of PDAs? Thank you. Yeah, if you mean the easier configuration of PDAs, yeah, PDAs are kind of issue to the fuzzing, because if you can insert just random addresses to the fuzzer, then it would be really simple. But yeah, PDAs are basically some expected addresses by the smart contract. So what we currently do is that you need to specify the seeds by yourself as you would for the integration tests, but we are trying to simplify basically we are trying to simplify this by macros. So you will also see in the hands-on example, so instead of calling the find program address and so on, you just specify basically the macros in the Trident are similar to the anchor macros used within the context. So yeah, it should be simple. Why we do that is because in the IDL, there are already some information about the seeds, but if the transformations of the seeds are more complex, more difficult, so for example, if we don't just use address of another account, but we do the transformation of the address, so we hash the address, once again, in that case, this transformation of a hash, this hash is not included in the IDL. So yeah, we can take the seeds logic from the IDL, but it wouldn't be completely correct in 100% of cases. If there is any script, not yet. But if you can think about some improvements that we can do, I forgot to mention this. If you have in mind some improvements, Trident is open source, so you can definitely contribute. Okay, it's 30, so I think we can continue to the hands-on examples. So let me share my screen. Okay, before we start, I think we can install the Trident from the cargo crates. So what can you do is cargo install Trident CLI, and I have specified the latest release candidate version, which is 0.11.0 RC3. So let me install it. Obviously, I already have it installed, so the installation was really fast. So let me.
Andrej, sorry, could you please increase the font a little bit more? It could cut the quality on the recording. Okay, yeah, that's perfect.
Is this all right?
Yeah, it looks great.
Okay. All right, so Trident is installed. Now let me go briefly through this smart contract. So what I prepared is really simple smart contract, which has 3 instructions. The first one is initialize, the second one is deposit, and the third one is withdraw. What I would like to mention is that this is actually the expected, or I would like to mention the expected sequence that I was talking about. So we expect that the initialize should be executed at the start, and actually, no. Actually, this is not. I created this yesterday, but a good catch. And then, yeah, so initialize should be executed at the start, because in the initialize, we actually initialize this bank account. And then there should be some permutation, some random sequence of deposits and withdrawals, because within the deposit, there is this amount on the instruction input, which we just add to the balance stored within the bank account. There are 2 issues within the smart contract. And the first one is that there is this unchecked arithmetic. So it could technically overflow. What Anchor does is that it automatically includes this overflow check, so it will not overflow but panic. So yeah, but we don't want to also let the smart contracts panic, but we would like to handle the panics nicely. So what we should do is to perform the saturating add or checked add. So that's the first issue, panicking behavior. And the second issue is that the update balance, the context used within the deposit and the withdraw, has incorrect constraints for basically who can perform the instruction. So instead of having the has1 constraint for the authority, the has1 is missing and the bank account is just mutable. And there are some errors, which is not that important from my point of view. So as I said, it is completely enough if you just execute Trident init. So let me initialize the Trident tests. If you see this message, everything went all right. You can see that there is this finished message. So the files were created, and there is some short message how to start fuzzing, but I know how to fuzzing, so I don't need to read it. What was generated is this Trident tests folder, and there's Trident TOML, Cargo TOML, and the fuzz test. What is slightly unlucky is that within the Cargo TOML in the fuzz test, we have specified that it is dedicated workspace. So for that, Rust Analyzer likely does not work in here. Why do we have separate workspace? That's because we don't want dependencies used within the fuzz test to mix with the dependencies used within the project itself. Because if you have, I don't know, older Anchor version, then there would be incompatibilities. So that's why we have a separate dedicated workspace. So let me go to the second window of the Trident tests. Almost. Okay. All right. I will again increase the font size. And this is the fastest just generated. So as I said, there is this Trident TOML, there is cargo TOML, and there is source code for the fastest. Before I go to the source code, what is important here is in the Trident TOML, we are including the build binary of the smart contract. So this is the address, and this is the path where the binary is stored. So typically target, deploy, and the name of the smart contract.so. There is this address. By default, fuzzing metrics are turned on, so you will see what is happening during fuzzing. I know that I will be using also dashboard, so I can turn the dashboard to true. Within the cargo TOML, there is not much important stuff, just the Trident fast dependency and the bin target as the fastest. If you have multiple fastest, there will be another bin target called, for example, fuzz1, and there will be another folder for the fuzz1. Okay, I think we can go directly to the fastest. So I will start with the main, as you probably are used to that Rust binary start with main. So let's start with main. We have this main function which runs as a fastest. At the main function, we create the instance of the fastest, and we execute the fuzz method, which is automatically generated by the flow executor. It is not important to see the source code of the fuzz method. What is important to understand is that we specify that we want to execute 1,000 of iterations, and each iteration will have 100 flows. What are, iterations, this is likely understandable, but what are flows? As I was talking about some expected sequence, so at the start of fuzzing the smart contract, you have the initialize instructions, then in the middle you have some permutation, and then in the end you have some termination instructions. Flows are actually how many instructions in a sequence you want to execute in the middle portion. So I have specified here two flows. Okay, in the flow one, you will see we will execute, or we want to execute withdraw, and in the flow two we will execute deposit. And this 100 means then within each iteration, create random sequence of deposits and withdrawals. So by default, the selection rate is 50-50. So there should be approximately 50 withdrawals and 50 deposits. Sometimes there will be definitely 48 withdrawals and 52 deposits, etc. But yeah, we want to have 100 flows within each iteration. All right, then we have these fields stored within the fastest, but I don't think it is important to comment them because Trident is just the field which is used to execute transactions, and then the fast accounts, which I will comment later when we execute the instruction. So let's start writing fastest. That's I would say the best option here. So sorry, let me see the. Sorry. Let me see the smart contract. So as I said, the smart contract has initialize function, instruction, deposit, and withdraw. So now let's fuzz these three instructions. Firstly, in the start, we want to execute the initialize. So initialize transaction. I will show you what the build does. This has to be mutable. And then when the transaction is created, execute transaction of the Trident, we can specify the X here. And the transaction name override, this is important in order when you have two same transactions executed, but you want to differentiate them in the fuzzing metrics, because fuzzing metrics collects metrics from fuzzing based on the transaction name. So if you have two same transactions, one will be called, for example, initialize one, the second one would be called initialize two. In this case, we have just one initialize, so we can specify something like initialize. And this has to be mutably borrowed. Okay, no issues, just a warning. In this first line, we build the initialize transaction, and the second line is for execution. Now, where are the random data? So if we go to the initialize transaction, you can see the transaction here, and the initialize transaction consists of just one initialize instruction. What you could do is to add there some additional instructions if you want, but we don't want to do that right now because we are completely all right if there is only one instruction in the transaction. As a good example are flash instructions. So if you have flash borrow, flash repay, some logic between, what would you do? Is that instruction one would be flash borrow, then some logic, then the flash repay. But in this case, we are all right if we just initialize the protocol. So let me click on the initialize instruction, and you can see the initialize instruction has accounts and data. And now we want to bring the randomness. How to do that? Firstly, we start with the data. So if you go to the initialize instruction, instruction hooks, you need to specify what should be the random data for the initialized instruction, if there are any. You can see that the initialize instruction is here empty, and you know it from your smart contract that the instruction inputs here are empty. So you do not need to specify basically any inputs for the initialized instruction regarding the input parameters. However, there are accounts that you want to specify. And these are bank account, authority, and system program. You know that the bank account will be PDA, and you know the authority is some kind of signer, some kind of wallet. How to do that? And here comes the fuzz accounts in hand. As I said, we cannot completely generate random addresses for the smart contracts because the random the PDAs, for example, are expected to have some kind of structure. The address is deterministically derived based on the seeds. So we cannot let the fuzzer, some kind of RNG, to generate random sequence of bytes, then turn the bytes into the pub key and then use the pub key as address. For that, we use the fuzz accounts as a storage. If I go to the fuzzaccounts.rs, you will see that there is the type defined. What it has actually. From the IDL, we take all of the accounts that are used within the smart contract. So you can see that's the authority, bank account, and system program. In this case, the account storage is just the hash map where you tell the fuzzer that to generate random index into the hash map, and on the index in the hash map, the pub key is stored. So instead of saying the fuzzer, create me random address, we tell the fuzzer, create me random integer from 0 to 3, so 0, 1, 2, and then the fuzz accounts actually map the account ID to some address. So in the initialize, if we want to specify that for the authority, in this case, for it to be simple, what we can do is that we specify storage name, but the range will be really simple, and we do just range like this. So what this does is that, give me a second. What it does is that we are saying the fuzzer generate just one index, just one account ID from 0 to 1. So it can be only 0 because it has to be, it cannot equal to 1, and assign address to it. If the address does not exist yet, create one address. Completely randomly generated. In this case, the completely random generated address is all right, because when we use the authority and the same principle in the deposit, we would specify something identical, but in this case, the address is already in the storage. So in this case, it will work. But if as I said, if the address would be completely randomly generated, then it wouldn't work, because the authority would be in every transaction completely different. So the fuzz account is just the storage, just the mapping from account ID to the address. All right, let me continue with the initialize. And yeah, storage name, sorry. This shouldn't be storage name, but storage account ID, and storage name is actually the field where we store the address. So once again, we are storing here the authority. We are just generating index from 0 to 1, so exclusively, so just 0, and that's basically it. We don't specify any seeds, anything in here. Where we need to specify seeds is the bank account. So in this case, we do the same thing. We need to specify the storage name. It will be bank account because the bank account has its own storage here in the fuzz accounts. We specify that we don't need multiple bank accounts. We are all right with just one, as also for the authority. So we do the same thing. I need comma here. But the bank account is PDA. And as it is PDA, we cannot generate the address completely random, but we need to specify also the seeds. If I remember it correctly, this is the static seed, and there is the authority and sref. Sorry, what's the issue? And let me make sure that it is correct.
Sorry, I don't understand.
Yeah, bank and authority. No dump. Oh yeah, I'm missing this B here. Yeah, exactly. Okay, no issues here. So initialize is all right. Storage name, or let me remove this and let me show you that we can already initialize the fastest. Okay, so within the main file, within the test_fuzz.rs, where the main function exists, we just builded the transaction, and we on the self Trident execute transaction, we call basically transaction execution. Now we can execute the fuzz test. Trident fuzz run fuzz 0. Is he audible? I'm not sure if, I hope you can hear me. Yes, okay. Okay, let me execute it. It will build for some time. Yeah, go ahead if you have a question. Okay. Okay. So yeah, if you have any questions for now, I think you can ask until it builds. Okay, so it already built. And yeah, you can see the metrics so far. These are the metrics. So what we can see is that the initialize instruction was executed. There are the total invocations. This number of transactions was successful, and there are failed invariants, instruction panics, etc. There are no such invariant failures. There are no such transaction panics because there is no behavior that could panic. We did not write invariants yet, and transactions did not fail because the seeds were correct, everything were correct. There were enough funds for the coverage of the rent, so it was all right. What we can do to better see the results, I was talking about the dashboard, which I turned on here. We can open next terminal and here perform Trident server. This will automatically start the HTTPS server, and we can have a look into the results of fuzzing. So you can see this is really simple dashboard. I would say maybe not that appealing because I'm not front-end developer, but yeah, it should be better than the CLI table, I would say. If you open the dashboard, you can see that there is total transaction executed, successful, failed, basically the same principle. And there are some additional metrics that can be debugged, but so far we were just executing just the initialized transaction. Okay, so I think we can continue to the deposit and the withdrawal, which will be definitely nicer, and we will see more results. As I said, we want to execute different variations and permutations of the deposits and withdrawals. So that's why we specify them within the flows. So let's do basically the same thing, but in the flow methods. Sure. Any question? All right. So you can see we are doing the same thing. We are building the transaction and we are executing it with the name deposit. In the second flow, let's do the same with the withdrawal. We can do the same thing with the withdrawal. Now, what we just need to do is to specify the account storages and the account IDs within the instructions. So let me first go to the deposit. Here in the bank account, you can see the cursor is already smart enough. So storage name, bank account, and to reuse every time the same bank account, we just specify this account ID range. For the authority, we do basically the same. However, you can see that there is this amount, which is on the instruction input, which you want to, this is like the simplest example of fuzzing something. So in this case, we want to fuzz this amount. So sometimes we want to send 0, sometimes we want to send 264 max, sometimes something in the middle. How to specify it? So that's the point where you work with the instruction hooks. You call the set data instruction, which sets actually the instruction data. And here, you tell the fuzzer to generate random numbers. So self.data.amount, and from the Trident, you can use the gen range method and specify the range. So from, for example, use 64, something like this. And I'm missing this thing and like this. Okay, so this is just saying that, yeah, whenever the transaction is executed, just use the random amount of on the transaction inputs. Let's do exactly the same for the withdrawal. So as you can see, cursor is already pretty sophisticated, so you can guess what should be in the accounts. And for the instruction amount, let's do the same. Now, we should be able to execute also the fastest with the withdraw and deposit. So let me keep these numbers here. So we have 1,000 iterations. Each iteration has 100 flows. So there will be approximately 50 withdrawals and 50 deposits. So let me run it again. You can see it was pretty fast. And yeah, you can see there are already some panics in the deposits. The initialize is exactly the same because there are no permutations of this start method. This is executed at the start of each iteration. Then there are permutations of flows, and there is this end execution. And yeah, we can see the deposit was executed 50,000 of times. Approximately half, 50% of times it succeeded, and approximately 50% of time it panicked, and we will see in the dashboard why. Then there is the withdrawal, and the withdrawal was not panicking, but you can see that it was failing for some reasons. Let me see in the dashboard why. So the server is running, and let's go back to the dashboard. We can see there are already the results. And if we have a look in the results, we can see that this number of transactions was executed. Approximately 50% was successful. There are some failures. We do not have specified invariants yet, so no invariant failures and no panics. If we scroll down, we can see the error details, and we can see that the withdrawal is only one instruction that is failing. So if we have a look in the view error logs, we can see why is it failing. And it is failing due to the insufficient funds, not enough funds to withdraw. And that's completely as expected because, let me open the window. That's not the correct window. Okay, this is it. There is this error if the bank account has not enough balance to withdraw, then the insufficient funds will be returned. So that is what is actually happening here. Now we can also have a look at the panics. So let me comment on it. You can see the deposit, and the deposit is panicking. Now we can see why is it panicking. It is panicking due to attempt to add with overflow. We can also see why is it panicking with the, or what was the instruction input, and you can see that these were the addresses of the accounts. You can also see which account was the signer, which account was writable, but you can also see the amount. And when the amount was some number, and we tried to actually add to that amount, the transaction started to panic. Okay, now I would like to show you the last thing because I can see that we have 2 minutes left. So let's have a look at the custom metrics to also see what are actually the numbers that we are fuzzing. Okay, so for example, you want to see what is the entropy of the deposits and of the withdrawals. So that is pretty simple because you can specify again in the Trident. So self the Trident, add the histogram metrics because these are histograms. You can specify the metric name, so it can be pretty simple, something like deposit and the amount that is deposited. And from where we take the amount from the transaction. So we can specify deposit dot instruction dot data because we can access it, and amount. Just yeah, and it has to be as float. If you remember, this is just building the instruction or transaction, and this is execution. So we can store in the histograms, we can store the metrics before the transaction is executed. We can do the same thing here, but with the withdraw and withdraw instruction data amount. Let me execute it once again. And for you to see the performance, let me increase this to 10,000. You can see that it is pretty fast. So it was 10,000 times 100. So it is 1 million, if I'm correct. And yeah, you can see the statistics, the probability, the results are pretty the same, just times 10. And now to have a look at the dashboard. This is basically the same. And yeah, now you can also expect you can also have a look at the results of the custom metrics. So we were depositing from this from range 0 to 64 max, but there is no guarantee that the 64 or the 0 is hit. You need to execute multiple fuzzing sessions, of course, because the U64 range is much bigger than the count of the transactions. So there is no guarantee that the 0 will be executed. But the edge cases, yeah, that's the art of the fuzzing. You can see the average, you can see the median, and you can also see the entropy. So, for example, if the entropy would be 0, that would mean that all of the numbers are basically the same. However, you can see that the entropy is 18 something, almost 11. So that means it is pretty correct because every number is unique to compare to others. Same goes for the withdrawal, where the entropy is almost the same, and basically the smallest number used for the withdrawal and the biggest number used for the withdrawal are different. If I run the fuzzing session once again, let me run it once again. If I run it once again, you will see that the numbers are different. Okay. So here are the numbers, something like 189, and here is 169, etc. So yeah, these are different numbers, different ranges, different numbers used for your smart contracts, and this way you can fuzz it. Of course, there are multiple and other features. For example, you can specify multiple instructions within transaction. As I said, you can do the invariant checks. I wanted to show you, but I don't have enough time. So yeah, that's everything from my side. And if you have any other questions, feel free to ask. Yeah, let me go through the chat. Okay. Okay, so 1555. Do you recommend running the fuzzer for those of us using Mac? Yeah, sure. If you are using a Mac, it will work correctly. It wasn't when we were using HonkFuzz and the AFL, but right now with the manually guided, it is working all right. I'm using also Mac, so Oh, sorry, make through a Docker. Yeah, it should be also possible to run it in the Docker. But yeah, I would expect that the performance will be, or yeah, the fuzzer will be slower, but I don't think it will be like tens of iterations per second. I would expect something like hundreds, maybe lower thousands. Which of the two is better, faster, and more variables for debugging when the fuzzer detects a vulnerability, HFuzz or FL? Yeah, both have their advantages and disadvantages. FL is more performant. I found HFuzz more suitable for debugging. Yeah, but hard to say. If you want to fuzz with AFL, the fuzzer needs to have some initial seeds created. We were handling that in the Trident with creating like a simple empty seed. In terms of finding bugs, yeah, I don't know for sure because we were not benchmarking them because we thought that, yeah, as I said, both have their own advantages and disadvantages. What might be disadvantage of HFuzz, which is pretty high disadvantage, is that HFuzz was not running on macOS. So yeah, for those who have macOS and are still using HFuzz and AFL, or are still using HFuzz, then use AFL. What does Trident error fail to find the root folder mean? If you are initializing the Trident test within the current protocol, it is kind of strange behavior. It shouldn't happen. You could see that I was able to initialize it correctly. So maybe you are in a actually bad workspace in the wrong folder, I would say. Does the folder has Trident IDL? Because yes, sorry, Trident IDL, Anchor IDL or Anchor Tombo, because what can happen is that if you're trying to initialize the Trident within the vanilla Solana workspace, it will not work because the Trident still by default tries to find the Anchor workspace. Yeah, what should we analyze further based on these results? This is a really nice question. So yeah, what I can see from the results. So yeah, I can see from the results that the initialize is basically working correctly because there are no issues. What I can see from the deposit is that it works most of the time correctly, this 50% of times, but the remaining 50% or 45% of times, it is panicking. So, and it shouldn't be panicking. The panics should be peacefully handled by errors or saturating math, etc. What would be even worse is that, as I showed you, that Anchor by default includes this overflow check flag to true. If you turn this flag to false, the math can actually overflow, and that's the behavior that you don't want to experience, because that would mean that from U64 you can turn the number to, I don't know, 0, 1, 5, etc. So yeah, this is actually the behavior you should observe, you should look for. You can see that, for example, the withdrawal is failing as expected and the errors are working because you are receiving the insufficient funds error. That's what you want to see, because you've stressed test actually the smart contract. So instead of going to the mainnet and praying that everything is working correctly, you can test it with this approach locally. You can also see the metrics here, which tells you that yeah, it is working correctly for this range of numbers. And trust me, this is big difference. I mean, when you take the minimum and the maximum. So yeah, this is big range of numbers, and it is working for 500,000 of transactions. So sorry, approximately 50% of this number. So yeah, you can expect that it is working correctly. Then if the invariant checks, this is the whole new chapter. If you have specified multiple invariant checks, that would mean that yet the fields within the data accounts, the data are basically updated as expected. You can use that for the regression testing. So you create fast test for some version of your smart contract, and then you do updates to the smart contract, for example, even big refactor, and you don't know if the smart contract still works correctly. But if you run the same fuzz test on it, you will see if the fields are updating correctly after the refactor. Because if the fields are not updated correctly after the refactor in the smart contract, then the invariants will show failures. Sure. Could you please explain what is the benefit of using Trident? It seems here that you wrote manually every unit test, then using randomized inputs and initialization clean instructions, which is exactly like cargo fuzz or libafl would do. What is the main benefit of using Trident? Okay, this is an interesting question. I was using really simple example. So I agree with you that this might be actually time consuming if your smart contract has, I don't know, 100 lines of code. But if you have smart contract which has 5,000 or 10,000, which is already common, let's say on the Solana, then in order to write fuzz tests for every math function that you have in the smart contract, it is not really that simple because the smart contract contains a lot of logic. That's the first thing. The second thing is that if you just take the math function, use it somewhere in different binary with some simpler approach, you are not mimicking actually the real world environment on the mainnet, but you are taking just the approximation or abstraction somewhere else from your smart contract to fuzz the math logic. So these I think are the benefits. The second thing is that I didn't implement the invariant checks because I was focusing really a lot on the initialization and writing or first steps of the writing the fuzz test. But if I perform the invariant checks, you would see that you can also see that some unauthorized withdrawals can happen with the smart contract, which can be identified by the invariant checks. So yeah, that's basically it. Yeah, as you said, this might look like similar to the integration test, but yeah, within the integration test, you just use this one number to test the smart contract. With the fuzzer, you can specify basically that's actually the second point. With the fuzz test, you can specify every input to be random. Within the integration test, you need to think about every possible input that's in the smart contract to test it properly for every edge case. And trust me, if the smart contract grows, there are the number of possible edge cases is drastically increasing. What if we want to set account ID in a guided way? Like I wanted to allow the ID which corresponds to the address which corresponds to the address which have a certain property, like it have already deposit position or it's have minted X number of NFTs, etc. Like if we want to have more guided fuzzing. Yeah. What you can give me a second. What you can do in the fuzz test is that, for example, the initialize. You can always specify that you want some account to have constant address always, and you don't need to withdraw it from the account storage. That's the first thing. The second thing is that you were talking about the token account. So let's imagine the deposit expect some token account. So what are the options for the token account? The token account for the deposit instruction or the deposit instruction already expects the token account to exist, or it will initialize the token account. If it initializes the token account, you can do the same approach as we are doing here, for example, without the seeds, and the deposit will initialize the token account. So the token account will actually exist on the address taken from the storage, and it will exist in the local client. The second, more difficult approach is that the deposit already expects that the token account exists and it have some amount of tokens. You can do that within the instruction hooks. So what you would do is that there is this fuzz account storage, as I was talking about, and there is also, for example, the bank account should be token account. So in that case, you need to allow token feature on the Trident. And here you will get access to get or create token account. And you specify the account ID, which is account ID, basically integer, but you can take the integer with the same approach from range. So sorry. I don't know, 0 to 1. Then use it here. And then remaining fields are just, for example, seeds. This can be none. And there is the mint, owner amount, delegate, that can be, for example, 0. Delegate is none. Some close authority. And in this way, instead of just generating the PDA or some signer wallet, you will, on that address, the Trident will generate the token account. There is the amount. So if the token account expects to have already some amount of tokens, this way you can basically use, I don't know, this kind of amount. So this amount will be added to the token account at the initialization. There should be in this free time. Can you please see pinned messages? Sorry. There are a lot of messages, so I'm trying to go through them. Can you please share the sample project? Yeah, sure. I can share it. SPL token program versus these programs, how they got routed. Show us the code if possible. To be honest, I'm not sure what you are asking about. SPL token programs versus system programs, how they got routed. Show us the code if possible. Currently, you cannot directly call system program from the fastest because yeah, you can set the accounts by yourself. So, for example, the self, the Trident. Sorry. There should be a method for that. Yeah, so Trident has method called set account custom, where you can set the account custom if you need it. But so far, I didn't need like custom accounts because either I dumped the account from the mainnet or everything was initialized by the protocol. So, but yeah, that's possible with the set account custom. Yeah, thanks. I would like to get in touch with you. I would like to collaborate and help you improve and add new features. Yeah, definitely. I would highly recommend you to collaborate on the Trident because it is open source, so feel free to open PRs. What if in set accounts, we want to skip this transaction? Like if it's trying to... Oh, yeah, I understand. Okay, so this is the state for fuzzing, and that would be required to actually deserialize the account. So oh, there it is. There is also the set account custom. So there is the set account custom. So you can specify the address and account share data which you want to store in the account if you want to initialize the custom account. But there is get account instruction. I don't know, account X equals, And this way you can obtain the account from the client and then perform deserialization. There is this file called types. So in the types, you already have the bank account. So we can deserialize the account into the bank account, and then it would require just the simple if statement. So if the deposits are not full, execute transaction. If the deposits are full, just don't call the execute transaction method. Sorry. Hey, Andrej, I have one request, and I think it will be beneficial for all of us. Before starting any lectures, can you please have a quick recap of the previous lessons? You likely mean the School of Solana, right? Yeah, I would say that's regarding the School of Solana. Can we control the sample rate of those flow functions during fuzzing? I like if we want to control some flows to be fast. Yeah, that's a really good point because it is possible. And you can specify here within the flow, you can specify that weight of this flow is, for example, 10. And here you will do 90. In this case, the flow 2 will be executed 90% of time, and this flow of 1 just 10%. And yeah, let me remove this thing. So yeah, instead of 50-50, this is 10 to 90. All right, we are approaching the end. I have likely missed it, but can you modify clock and addresses vars from? Sure, it is possible. What you can do here is that self Trident get client, and within the client there is get sysvar. And what you can do is, for example, like this. Take it from the SDK. You can see you have the clock. Let me turn it to be mutable. In that case, let add to the timestamp. Just 1 second. And then you can do yeah, you can do it this way and call set account custom. And there is also another option, and that's sorry. Warp to timestamp or warp to slot, warp to epoch, and also forward in time. So this would require you to set the account custom method, and this is just forward in time by 1 second. If you want to, for example, the fuzzing session to always start at the same time, you can do at the start, at the complete beginning, sorry. You can perform something like warp to timestamp, and here use 100 or 10,000 or something like that. And the timestamp will be always set to this number at the start of each fuzzing iteration and each fuzzing session. So that's important to mention. So it will, every time it will be 10,000. Yeah, does it support executing the long running fuzzing jobs? Yeah, I think so. And yeah, so I can see that there are no additional questions. So thanks for your attention. Thanks for your questions. If you have any other questions, feel free to reach out to me on Discord. We have Ackee Blockchain Discord channel. Feel free to write me on Twitter. I will definitely write you back here. If you have any issues, feel free to open issues on the pull request. Feel free to create, on the GitHub. Feel free to create pull requests on the GitHub. We are open to collaboration. So that's basically everything from my side. Thanks for the nice emojis, and yeah.
Thanks a lot, Andrej, for joining today. We'll publish the recording and notes and everything on YouTube, I guess, by the end of the day tomorrow, and we'll announce this on Twitter as well. So yeah, thanks a lot for joining. And yeah, if you guys have any more recommendations on who should we invite for guest lectures, feel free to also tag us on Rectov or DM on Rectov Twitter, and let's be in touch. Thanks everyone.
Yep. Thanks for a great audience, and yeah, enjoy the rest of your days, guys. See you. Bye.
Bye-bye.